Okay, so how to do that? I'll show you. So, uh, yeah, semaphores. This is what I said: integer value, no restriction, binary semaphore. Another name is called as mutex lock. In all your competitive exam question will be like mutex lock. They will not use binary semaphore. It's nothing but binary semaphore only. Mm, okay, so this is the implementation part for to control busy wait. So we have a busy wait, that is a spin lock. How to overcome that one as a, they have given note that application may spend lot of time in the critical section. Therefore it's not a good solution, because consider if p1 spends 1 hour in the critical section, p2 will be spinning there only, no? So that's not a good way of programming. So what we do is, we have to implement semaphore in such a way, there is no big, that is what they have given: implement semaphore with no busy wait. So using what? Two operation. That is what block means: put him to sleep. Wake up means, you should, after critical section is available, that process which is put to block should be removed from the blocked state. That is wake that process. So we have a two data structure struct. So we have a one variable called as value. I'll tell you what for we are using, and a list called as list. This list is used to store what processes which we want to block. So this list is to store a many processes which are ready, but critical section is not available. So to move those process to waiting state, those process will be added to this list. Okay, so now, so wait of, sorry, so two methods are there where we can use your s, that is semaphore. So only in your wait and signal only code should be changed, otherwise it is same. Wait of s, critical section, signal of s. Wait is to give only the lock to one process, signal is to release the lock after the use. But what we have to write here is just to do s of value minus minus. That is what we did in the last thing also, no? Decrement s value by 1. Okay, consider if second process p2 tries to enter, next p3 tries to enter. Every time you decrement, it will go to negative value, right? So when the negative value is not, if negative value, s value is negative, then what you do, you add that one to the list. List is like your memory location where you're putting all the processes which are wanting to go to the critical section, but critical section is not available. So you're sending those process to s and you're blocking it. Okay, next, then if a process is already there in the critical section, after that it will exit, no? When it exits, signal program segment should be executed. In the signal, what we are doing, how, like previous thing, we are incrementing by 1. After incrementing, if you see any value which is still lesser than 0 or equal to 0, means indicates what? There are some process in the list, right? There are some process which are waiting in the list, and now it is waiting, and you have to move from waiting state to ready state. So this is the call, wake up call you're giving to process. If n processes are there in the list, you are applying first come for if FIFO queue, like it's a FIFO queue. So the first which is like a FIFO, you're selecting one process from that list, and then that one process which you're selecting from the list will be waked up from the waiting state to the ready state, and that can enter next to the critical section. So here nobody is stuck inside a spin lock. If there is no while loop, you can see here there is no while loop, infinite while loop to struck inside a lock, spin lock, or a busy wait. So that could be achieved using this three lines. That is, whenever a semaphore value is negative, indicates that process should wait. But cannot be in the busy wait. But that is it cannot be put inside the spin lock. So we move that process from the um, that state state to a list, store it there and block it. When a process exit critical section is available, remove one process from that list, wake up that list so that it can enter into critical section. Waking up means changing the state from waiting state to ready state. Means ready state means no process states. Waiting state to ready state means it can enter into critical section next. Okay. I know if you are listening to me, you'll definitely understand. Please understand, in textbook also they have given that equal to false, true, minus, negative, taking n number of process, that all not given. Please take 4 to 5 process and write, trace it and see, definitely you will understand. This part is to block if anybody is ready, but see critical section not available, put into a list and block it. Once process exit from the critical section, it is available, so remove one from the list and wake that process up so that it can move from the waiting state to ready state. When it is in the ready state, it can enter into critical section. Okay, that is all about semaphore. So we have a concept here called as disadvantage, called as deadlock or starvation. If you see this table, there is a process called as P0 and P1. Weight of S, please don't exit. I have not taken attendance. I'll complete this one and I'll take weight of S and Q of S. So leave it. I'll cover this one in the next class. Let me take the attendance first. Sneha, don't leave. I have to take attendance. So everybody has typed in your name and USN, right? If not, please type. Arey yaar, I exited, no. Please type, check the chat box because I actually my call got disconnected. So please type in fast. Yeah, it's got recorded. Whoever typed, you can leave. Thank you. Paul. Yeah, done. Everybody typed no. Okay, thank you.